And a little introduction. I am Peter Smith from Roderick James Architects. I'm going to talk about the COP26 house that we built for COP26, obviously, in Glasgow a few years ago. Give you an update on where we're at and where we're heading. So, without further ado, I shall start with a little bit of background. The whole idea behind the COP26 house came from the fact that I live and work in Glasgow, and I felt that with the eyes of the world upon us during the COP26 event, I thought it would be a great opportunity to showcase to the world what we are able to do in this country at this time with the skills, the materials, and the technology that is readily available. It's not rocket science. We can build zero carbon houses at this moment. We don't have to wait until 2030 or for any new technology to come on board. It's all doable right now. And so I took this idea to build this showcase house around the country to a lot of the companies that we work with regularly, a few new companies as well, to see if they were interested and see if they would come on board with this project. And luckily for me, they all pretty much jumped at the chance and very kindly donated their materials, their expertise, their time, and some money to the cause to help deliver this house for the COP26 event. So we formed a kind of loose organization of these roughly just over 20 companies to deliver this house, and we called ourselves Beyond Zero Homes because it wasn't just about being zero carbon, it's about showing that zero carbon, healthy, affordable homes can also be beautiful and great places to live. Looking at a little bit of the background, the why bother with all of this, I'm very conscious. I'm speaking to the type of people that already know a lot of these kind of numbers and things, but a few summary, big figures, I guess, is the extent of the UK carbon emissions that are attributable to the built environment, specifically for me, residential buildings, how currently the embodied carbon forms quite a large proportion of the overall picture, and as buildings become more energy efficient, that embodied carbon is that proportion is going to increase and become more of an issue as we go forward. Another, obviously, there are loads of kind of facts and figures and numbers banded about, but for me, it's the idea that what we do with one individual house might not make a big difference, but the fact that we need to be building hundreds of thousands of new homes every year, and making a small change on one of them will obviously create a massive change across the industry. And then also, what's very important for me is looking around at what we have done in the past, and high-rise buildings in Glasgow being pulled down. I think we've lost nearly a quarter of the high-rise buildings in this city in the last 20 years while I've been living here, certainly. And they are full of embodied carbon. They're big concrete blocks, almost whole villages of people. And we're pulling them down, and often it's not actually the buildings that are to blame. It's the infrastructure around them that isn't working, and So there's that whole concept, but also the idea that what we are building now to replace those buildings, uh, we need to think about how they're built, how long they'll last, and what we're going to do with them at the end of their lives. Because rather than blowing them up and turning them into rubble and landfill, we should be thinking about how we can recycle them and reuse them in different ways in whatever, 60 to 100 to 200 years time. Just a little bit of background about ourselves. Roderick James Architects, we're one of the leading UK timber house designers. Lots of projects all over the country and abroad as well, but mostly in the UK. We have worked a lot with BSW Timber, a large timber supplier, sawmilling group, now part of Binderholz from Austria. We've worked over the last 15, 20 years with BSW to encourage the use of homegrown timber in the UK. And so we took our barn house, which is one of our signature designs that we've built many variations of all over the country over the last 20, 30 years. And I took one specific version of that barn house, which we had developed with BSW for a site in Botegarten near Aviemore, close to one of their sawmills. They had an empty site and asked us to get planning permission for 12 affordable houses, and this was the smallest of those 12 houses. So we took the barn house, took it apart into its constituent elements and looked for the carbon hotspots. So obviously things like the concrete foundations and masonry, structure, cladding, that type of thing, obviously has high embodied carbon. But other things like PV panels and the whole M&E side of things was a surprisingly large proportion of the overall carbon footprint of a building. So we looked at these hotspots and then put the house back together again, um, trying to eliminate those hotspots as much as possible, and then sorry, compared what we had achieved to the RIBA 2030 climate challenge targets. And happily for us, came in well below the target that RIBA have set for embodied carbon for the year 2030. That was business as usual back in the days of COP26. We're already at 2025. Time is marching on, and we really need to be focusing on addressing these issues. We've got, like I said, I think maybe two build cycles left between now and 2030. So we don't have the luxury of being able to learn from our mistakes. We need to get things right first time. Looking at the numbers again, if you think back to the slides previously, saving 8 tons of carbon on a small house like this maybe doesn't make a massive amount of difference, but saving 8 tons per house when you're building 300,000 houses a year uh, will make a big difference. And then through the course of it, this was a learning experience for me as well, and through the course of the process of looking at the embodied carbon for the COP26 house, we looked at various aspects of that. Obviously, most of the embodied carbon lies in the materials, but a large chunk of it obviously also comes from the replacement of those materials, and then thinking about how we can reduce that or reuse um, different elements at the end of their, whether it's a 10, 15, 20, 30, 60-year lifespan, depending on what part of the building we're talking about. This is a slide that I quite like. Within the life cycle assessment of a building, we are allowed to present the embodied carbon of the kind of construction phase and in use. But what doesn't come into the calculations is the amount of sequestered carbon that we store in the building by choosing the right materials. So obviously natural materials, particularly timber for structure, and we used wood fiber insulation, um, and we're able to store within the fabric of the building more than twice the amount of carbon that was created in its construction. And here are some photos of the cop house being built. So you can see the wood fiber insulation in between the timber structure and also wrapping around the outside of it like a tea cozy. Also on the inside, almost everywhere where we possibly could, we used timber. So timber cladding, painted white on the ceilings, and in many of our houses we leave it looking natural. Um, Timber framed windows, beautiful timber furniture. Yeah, wherever possible, we use timber. Even on the roof, we used board on board, um, kind of timber detailing that kind of resembles corrugated metal,
Mhm.
and that was using Scottish larch that we got from BSW. All the cladding for the whole building, almost all the timber for this building came from BSW.
And Peter, I mean, we're focusing a lot on embodied carbon here and the actual materials. When it comes to the comfort of the homes, um, what sort of heating system and hot water system are you putting in, and are there even heating systems required?
Yeah, I mean, we designed the building to Passive House standards, and so the for a small building like this house was 50 square meter footprint. It's got a small mezzanine that has can be used as a kind of sleeping platform or a home office. So it's a small building. It doesn't need a lot of heating anyway. But for the COP26 house, if you remember, we looked at the kind of embodied carbon of various M&E
Mm,
solutions. And for this one, we decided rather than putting in an underfloor heating system, which would have had to be ripped out at the end of
yeah,
the COP event, everything that we did, we had to think about what are we going to do after
yeah.
COP26. So that became a very important feature of this house. And so for the COP26 house, we ended up using infrared panels that we got from Herschel.
Hmm.
And they, I have to say, were absolutely great. The COP26 event was obviously in November. It was freezing cold outside. You came into that house, and I mean, yes, it was designed with a big glazed frontage, all pointing south. So the house heated up very nicely with the low sun in the winter. Triple glazed windows kept the heat in.
Hmm.
The U values of the walls and the roof were 0.12, so decent level of insulation. So once the house was warm, it kind of stayed warm. We had lots of people milling around, lots of bodies creating warmth. But then, the door was open a lot of the time. There were people coming and going a lot of the time, and it always felt cozy in there. And those infrared panels were great. They kind of, I don't know if everybody knows about how they work, but effectively they work in the same way as sunshine. So it's like having sunshine coming in through a window shining on you. So they don't heat the air,
They heat
or
you.
they heat the objects that they are shining onto. So it's like on a cold winter's day, you can sit outside. The air might be cold, but if the sun is shining on you, you feel that the warmth of the sun on the back of your neck. It's that kind of heat that you get from infrared panels.
Hmm. Thank you. I've got a
We
couple of questions.
also
Oh, sorry, go on, Peter.
Yeah, we also had an MVHR system from Paul Heat Recovery. They donated that. It was an extremely oversized system that we had in the house. It was, I think, one that they had anyway, but they donated it to us free of charge, which was great. And it was a good showcase for them, and we could show. I think you can see in some of the images there, you can see the metal ductwork, and we had to take that into account as well through the embodied carbon assessment. You know that even things like the ductwork make a big difference when you're trying to hit these kind of targets.
Cool. Um, I've got a couple of questions, Peter. I just might as well bring them
Sure.
in now. I'll
Go
save
for it.
Keys's to the last because it's quite a large topic.
Uh-huh.
Brian's picking up on your timber roof that looks like a traditional metal roof. What is the lifespan of your roof or of that roof?
Yeah, I think we had when it's treated like this, the BSW product that we used, it's called IRO, and it goes through a treatment. It's similar to the kind of Shosugi ban treatment, kind of Japanese charring
Mm,
uh, of timber. So it's Scottish larch. It's been charred and then dyed with a kind of protective colored oil, and uh, and goes through 7 different stages of treatment. So the lifespan for the wall panels, I think it was guaranteed or whatever for something like 20 years. For the roof, it was something like 15, but with a bit of care and regular kind of maintenance, I think you could expect a longer lifespan. I'm not entirely sure, and for this house, we it was deliberately focusing on reducing the embodied carbon. So the solutions that we came up with for this particular house are not going to be the correct solution for every house in every location. And what you do in a kind of urban context is going to be different from what you do in a kind of rural environment. So I'm not saying that this is exactly what has to be done on every single house. It's really just to show what we have learned from going through this process of building the house for COP26.
yeah, and taking in the deconstruction and reconstruction into
Yeah,
account.
exactly. There's
Yeah,
lots of decisions that we made that were specific to this house.
yeah, yeah.
Um,
So whilst this is based on a theme of one of your barn houses that Roderick James provide, obviously, as you just said, it's not. This is not the house that people would end up living if it wasn't a COP26 deconstruction project.
exactly, exactly. So I don't know if you remember some of the images from the start of the slideshow. A lot of what we do is kind of based on oak frame building
Mm,
with traditional mortise and tenon joins and um, a larger a larger section timbers spaced out usually every 4 meters or so. Whereas on this house, I was trying to use homegrown timber.
Yeah.
smaller sections. So you can see on that main internal slide or on this one, the main structural elements were much smaller than you would have with a traditional oak frame, and they were spaced out at 1.2 meters centers, designed to actually be built or buildable by two people. So these panels are 1.2 meters wide and can be uh, built and lifted into place, obviously with hoists or cranes, but can be maneuvered and managed by two people.
Hmm.
So that was to make the construction easier, but also to make the deconstruction and removal process easier as well. So
Cool.
that's maybe not something that would be relevant for somebody else's project. You might make prefabricated panels that are 4.8 meters wide, for example.
Yeah. Brian's just picked up on the infrared panels as well. They need to be ceiling mounted for efficiency. Um, I, I know that's commonly
You
used in
get all
schools. It
sorts
doesn't
of
have to be, does it?
different. There's it's amazing how many different project products there are on the market now as well. You
Yeah.
can, for example, you get infrared heated mirrors.
Yeah.
You get heated skirting boards, heated entire wall panels. There's all sorts of things out there. It's
Yeah.
quite interesting what's happening in that space
Yeah.
now.
Yeah. No, because we've had on Ian's asked about the manufacturer, and in this instance, it's Herschel, Ian. But I also know we've had both Herschel present on a Meshwork webinar previously,
Okay.
but also Rod Davies from or his company's called Energy Carbon. They also provide
Uh,
infrared heating as well. They do a lot for social housing, and they call them like fleeces, where they put the fleeces on the ceiling. So I'm just putting that in the chat.
uh,
In so that yeah, as Peter said, there's lots of manufacturers and suppliers, and when it comes to, I quite like the product. It's called Thermoskirt, and
yeah,
they're in their stories that they want to be a replacement for ugly radiators or just radiators, and you sort of get heat pump ready by installing um, skirting boards that are essentially plumbed into the system.
yeah,
So there's
yeah,
all types of different things that you
yeah.
do. What the other one? Peter, Paul asked, could you say more on the B4 replacement materials and what these might be, if any, in this house?
Yeah, good question. Obviously things that I mentioned, like the roofing materials, might be replaced once or twice during an average lifespan of a building. Things like windows will get replaced, depending on the quality of the windows, but they could be every 20 or 30 years. I think for your average life cycle assessment, they go on the assumption that a building lifespan is based on 60 years, which seems very short
Yeah,
to
it
me.
does.
Um, but for example, that might involve replacing the windows possibly two times if it's every 20 years. Um, in that lifespan. But things like the internal fittings, a kitchen could get replaced every 10 years. The internal cladding, you might get some damage to the flooring or, things like that could get replaced on a more frequent cycle than other elements like the external cladding maybe on the walls that might have 25, 30-year lifespan. And a lot of it depends as well on how well you look after the building. A lot of people, I think, nowadays expect uh, to move into a new build house and not really have to do much to it, whereas 20, 30, 50, 100 years ago, you were kind of whitewashing your walls on your little croft house every couple of years, and dealing with holes in the roof and things like that. So
Mm.
yeah, it's quite an interesting aspect of um, the kind of ongoing life cycle of a building that it never really stays the same for a very long time. Things do get replaced through general wear and tear and weathering, and things have a natural kind of lifespan. And of course, with natural products, uh, those lifespans might not be as long as they would be with kind of metals or plastics. But even PVC windows and plastic guttering and a lot of the kind of plastic fascias and barge boards and things like that. They can look quite ugly and need replacing uh, even more than timber.
Mm.
Timber for me, as it ages, actually gets more beautiful and gives a building some character. Different people will have different opinions about that, I guess.
Of course. And then do you, in terms of from an insulation perspective, is it always, have you always used the type you explained, or have you considered things like straw and wool and
All
other
sorts.
materials?
Ever since I started working for Roderick James Architects in 2010, and since then have only really been using natural materials wherever possible. Certainly in the walls and the roofs. In the ground floor, it's not always that easy. But for example, top left there, you can see the floor construction. We built for COP26. We built this house just on railway sleepers on an existing concrete floor slab. With this site, there used to be a petrol station on this site, and so we laid down some railway sleepers and just had enough air going underneath the building. But as we've rebuilt it, I'll get to those slides
Mm.
soon. We ended up with three concrete strip foundations, which of course will have an impact on the embodied carbon. Um, but yeah, back to the question about insulation and natural materials. We've used hemp, wood fiber, sheep's wool. Um, Yeah, all sorts of kind of different natural materials wherever possible, and as long as the budget allows for it as well. I'm finding nowadays that there's very little difference between the kind of natural breathable materials and the less attractive alternatives that are also out there.
Cool.
Much of a muchness price-wise these days.
Hmm.
I'll
Yeah,
keep
sorry, I'll let you get on, Peter.
keep going. But
Yep.
yeah, totally happy to answer any questions as they come along. So yeah, back to the kind of numbers involved. Looking at the embodied carbon, you can see the three kind of major aspects for this building: the ground floor, the roof, and the external walls. Obviously, that's where most of the materials lie. But also, this is where you can sequester a lot more carbon as well, because that's where you can pack in a lot of the kind of the timber and the natural materials to store the carbon. And then on to the next kind of evolution of the house. Obviously, it was designed for a very short period of time. COP26 only lasted a couple of weeks. The house was actually there for a couple of months. We had lots of visitors after the COP26 event, but then after a while, Glasgow City Council, who owned the site, needed to have the site back, and so we dismantled it. It was really quite quick to take the building apart, and this is a kind of photo from the site next door, looking down. This was it after the COP26 event. Um, Packed up and ready to go. So it went into storage at Glasgow College for a while. They were hoping to rebuild it on their own campus as a learning facility for their students. Sadly, it didn't work out, but we found this other organisation, Rothiemurchus Estate, near Abbeymoor, actually very close to the site that the house was originally designed for BSW at Boat Garton. And so it's kind of gone through a kind of a nice kind of full circle back to where it came from, and is being carefully rebuilt by Rothiemurchus Estate for either for a holiday let or as a kind of starter home for one of the estate staff, as a kind of affordable housing offering for people on the estate. So this is it being rebuilt. Quite similar photos to what we had in Glasgow, but luckily it seems to have gone together really quite well. Despite having been in storage for a year, and it's gone through the kind of transport process. A few things have had to be adapted. Remember me talking about the timber roofing. There were some issues during the reconstruction. Some of the panels got damaged, and boards got damaged. Some different things went missing. So they ended up using corrugated metal for the roof, which for me it was a big shame, but it had to adapt to the new owners, and to what they were able to work with. And so yeah, that's one aspect of the building that maybe in future the roof panels could be designed to be taken on and off in a better way to avoid damage to the external boarding. Um, but yeah, apart from that, a little bit of insulation kind of suffered during the transport process, so they had to replace that. You can see some of it on the inside there, but this photo here was taken a couple of weeks ago, so it's getting there. It's going to be another few months until it's ready, but hopefully by the summertime, it'll be open and usable again. And I'm hoping to maybe spend a weekend up there myself at some point, just to test it out.
Fully
See.
deserved.
Yeah. It's funny. I do. It's almost like you get a kind of attachment uh, uh, to the buildings that you work on, and it's just nice to see it
Hmm.
coming together again. And that's the kind of full circle thing. That was a
Identical.
few years ago in the middle of Glasgow, and this is it being rebuilt in its hopefully forever home.
Yeah.
And hopefully it'll get a lot of good use, and people will enjoy living in it.
Yeah, definitely. No, well, thanks for that.
There's a few quick more slides. How am I for time? Actually, all
Yeah, we're
right.
doing okay. Yeah.
Just I have in the past had a lot of questions about the build process and what it costs. If you remember right at the start, I showed you that group of 25 companies that contributed as part of Beyond Zero Homes. they all provided their materials, their technical know-how, their time, their expertise, free of charge. And we asked them in the future, if someone wanted your materials for a house like this, what would you charge them? We added it all up and it came to around 140K. Now that was 2, 3, 4 years ago. Um, Nowadays that might be as much as 160, 170, maybe even 180, depending on the spec. So, that has to be kind of taken into account. But it was an extremely fast build process. We were given the site at the beginning of September, and COP was at the beginning of November. So, the whole building went up in 8 weeks. It was a couple of weeks off site in the factory, building the panels, and then 8 weeks on site. Deconstruction took about 4 weeks. And now the reconstruction process has happened over a course of about 6 months.
But that's because it's not their main priority.
Exactly. It's
Yeah,
it's Rothiemurchus Estate. There's a few kind of joiners and builders who work for the estate that
yeah,
are carefully, slowly
yeah,
putting it back together. Um, some slides about other houses that we've done in the past based on similar idea and similar build systems. So that the what we did for the COP26 house could very easily be adapted for lots of other house designs. It's not just the COP26 house that works with the same uh, concept. Um, Three little designs there: the Fair and Square, the Croft House, and the Forester's House is a semi-detached 3 or 4 bedroom option. And that is kind of it, really. Come and find us if you're interested in chatting some more.
yeah. Cool. Thanks, Peter. No, I'll share these links when I
Yeah,
provide the video on meshwork. I mean, it just goes to show what can be done. I know it's obviously quite a niche task that you set yourself in terms of the construction and reconstruction, but it's really interesting to sort of how you challenged yourselves and how you challenged the wider industry to build better homes. And I
yeah,
suppose um, well, before I come on to Kingsley, just Sybil's asked, and she obviously thanks you for sharing the details. I mean, I know when we initially spoke that you were, it's like Sybil's asking about, do you plan to monitor the building in the future, occupancy, feedback, etc., etc. That's obviously part of your goal as well. And you were hoping that, okay, it's taken a team 6 months to date, or sorry, it's taken a team longer to reconstruct the house just because of it's not their priority. But I know that that's an aim of yours, isn't it? In terms of
yeah, yeah, definitely. The whole idea behind Beyond Zero Homes was
yeah,
that, and it's something that I'm probably most proud of was the way that all of us came together. We had these kind of teams meetings with 20 people all coming up with ideas and how are we going to make this work? And we're under extreme time pressure to make it all happen. But it was like really inspiring seeing these companies who normally on a normal, very contractual build process, everyone is kind of being a little bit guarded
yeah,
and careful about what they commit to and things. And on this, everyone just piled in and said, how can we help? How can we make it happen? And that's what we need in order to deal with the climate crisis. We all need to kind of collaborate and help each other and learn from projects like this. And that's why I'm delighted to talk about it
yeah,
all the time.
yeah. No,
I think it's
absolutely. It like,
important that that message gets across.
yeah, it goes to show what can be done and how the large house builders can take note and do more
Yeah.
essentially. I mean,
Yeah.
King's made the point that he was talking to someone and they were raising the point that it's impossible to build all the homes we need in the UK whilst meeting carbon commitments. But I don't know the answer to that, and I'm not going to pretend. I'm not even going to give it a go, and it's a bit unfair on you to comment unless you want to. But ultimately, it's regardless of whether we build every house in this manner, we try. It goes to show that it's possible that even a new home that is built can be built better,
Yeah,
regardless of what the target is or
absolutely.
having
And
been done.
and I think what's important about this project is this is just one tiny example of
Yeah,
a group of people coming together and achieving something amazing, And if of course the scale of the problem that we're facing is immense, but we're not going to fix it by sitting on our hands, And I think just everyone doing a little bit and working out and then sharing the knowledge that they've learnt from each individual project. That's the way that we'll make a dent in the problems that we're looking at the moment.
yeah, no, absolutely. And then just one last question. Paul's just made a point about foundation strategies and reducing embodied carbon within them, talking about their reusability. Um, yeah, I mean, saying I don't, maybe less considered. It's just a more of a challenge. I mean, again, we've had, I can't remember her name now, Beth, structural engineer, that did a session on um, sort of less carbon intensive foundations, and there are a number of alternatives and options.
Yeah.
Not least, I mean, was it car tires, tractor tires, and rubber, all sorts of.
Yeah, there's all sorts of, different things out there and some are fine. Like for example, I was working on a project recently, a zero carbon bothy in the Cairngorm National Park as part of a reforestation project. And for that one, we used boulders as the
Mm,
foundations. And obviously, you can't do that on, like with the COP26 house, we used railway sleepers on a concrete slab. You can't do that on every project, and there'll be different solutions for different scales of projects. But there's lots of companies out there who are looking at, green concrete and um, yeah, all and even, things like the insulation that goes in the ground, whether it's recycled glass, pearl,
yeah,
blown glass, that kind of thing. There are different options and things are changing. Every time you Google it, there's something new that comes up. So that's an area where things are changing rapidly, and we just got to, as architects and clients and things, just keep demanding from the industry, and then by choosing better options, it'll help drive the change that we need. Like the suppliers are coming now as they realize that clients are looking elsewhere. Then we've had CPDs within our office from companies who are looking at alternatives to the kind of high
yeah.
carbon concrete um, and insulation products.
Absolutely. No, definitely, definitely. Yeah, I mean, again, when I phone around and speak to architects as part of my role with Mesh Energy, and there's clients, homeowners are asking more about these types of things, renewables and the fabric, and making sure that they can minimize their carbon footprint as much as possible. I mean, it's yeah, it, and then equally, going. So the individual is taking responsibility, but then the large house builders, they are adapting as well, albeit probably too slow in many people's eyes. But Peter, thank you very much for that. I appreciate you taking the time, not
Thanks
least
for inviting
today, but
me.
also the conversations we've had previously. So many thanks to all our speakers, because I know it does take time to prepare for this. So yeah, I know everyone appreciates it, and yeah, thanks for joining. Thanks for all your questions, and yeah, check out the Meshwork website for future webinars, and I hope to see you all soon. Cheers, guys. Thanks, Peter.
Here's Simon. Thanks, everyone.